Good morning, everyone. I'm here. I'm myself, Dr. Om Prakash Sharma, Professor, Department Electronics and Communication Engineering, Poonima College of Engineering, Jaipur. I'm here with my presentation, Wireless Communication, wherein I'm focusing on a defined topic, frequency reuse, which is an area which is of utmost importance when we understand wireless communication in a deeper context. Objective of this presentation is to make student understand the concept of frequency reuse, planning, and to promote student to self-analyze the frequency planning and reuse technology in the wireless communication. The brief contents of my presentation will have and focus on frequency reuse, planning, cell structure, co-channel adjacent channel interference, system capacity, increasing the system capacity, and various references. Coming to the terminology frequency reuse planning. In general, what we do is the same set of frequencies is reused to provide the service to the subscribers. Suppose there is same say defined set of frequencies and we want to have more and more subscriber to substitute the frequency. The frequency reuse is the, you can say frequency reuse of planning is the way means out to provide the services to more and more subscribers. This in fact is basically the process of improving the efficiency of a cellular network. We know that we do have radio spectrum which is limited and we have got number of subscribers to substitute the services. Frequency planning and reuse is the way out. Fact is, after a distance a radio wave get attenuated and the signal falls below a point where it can no longer be used. Now coming to the cell structure, which is again very important one. Shape of the cell to cover the area is at most importance. We have got different geometries right from starting when we have got too much research being developed in wireless communication. We have got the circular shape as already being projected over here, and also we have got you can say the square, which is again shown in this particular diagram. Circular shown over here, we have got the square shape and we have got the hexagonal shape, and we can directly see when we talk about the square, which is not an ideal geometry. Four neighbors in square, if we talk about the four neighbors like 1, 1, 2 and 3 and 4, these four neighbors, they have got different you can say distance from here to here. If we talk about 1.414 d, and from here to here again small d, that means there is variation in between neighbors as far as the distance is concerned. If we talk about the circular geometry, we have got the gap in between over here, and we cannot substitute the services if the subscriber moving within this particular gap. Hexagonal shape F, if we talk about, is the ideal geometry wherein we have got each adjacent cell center is at d is equal to root. This is basically root of 3r, where r is basically the distance of hexagonal cell. Coming to reuse pattern, we have got various patterns and different you can say the nomenclatures are being used in frequency reuse. We have small capital D, minimum distance between center of cells, that use the same set of frequency band, which is also being referred as the co-channel, wherein we have got various you can say nomenclature. Capital R, radius of the cell, D, distance between center of the cell, and N is basically the reuse factor. In a hexagonal shape, we have got N possible you can say clusters or number of cells which can be clustered together, wherein N is being related along with the I square plus J square plus I into J, which is basically shows which way the hexagonal pattern and reuse. N is basically the reuse factor, can be clubbed together, and the values of N can be using these equations, we can say the values of n can be 1, 3, 4, 7, 12, 13, 16, 19 and 21. The relationship possible between the d, capital D, small d and root of n or reuse factor can be denoted by this equation as well as by this particular equation. D upon R is equal to root of 3n. We can just see a reuse factor n is equal to 4, wherein we have got 1, 1, 2, 3, 4. Same way, if we talk about the 7 cell reuse, we have got 1. Same way, 1, 2, 3, 4. This, or here we can talk about 1, 2, 3, 4. N is equal to 7. For n equal to 7. Reuse factor. Coming to co-channel, adjacent channel, it is very important because if we see this particular cluster, we can find out that this reddish one, this two reddish one use the same set of frequency. Same way, this bluish one will use the same set of frequency. Here this will have the same set of frequency. Here also same set of frequency. Now the most important thing is the same set of frequency should not interfere with each other. This is being referred as co-channel. The co-channel, the word co-channel, this word is basically dedicated to this all, co-channel. Same way, if we talk about the adjacent channel, these are basically the adjacent channel. These are two adjacent channel. These are adjacent channel. These are adjacent channel. Adjacent channel have got different set of frequencies, but co-channel has got the same set of frequency. The main objective is in if we talk about co-channel or adjacent channel, there should not be any interference. For n is equal to 7, it is being projected adjacent channel as well as the co-channel. Increasing the capacity. The thing is, once the network is being there and more subscribers are coming, how to increase the capacity of the network? There are various approaches that are being employed. Some approaches are basically adding new channels as being projected over here. We have got the new channels. What happens is, when the network is being there are few channels which are being employed and the rest of the channel are ideal. We can go for the new channels, adding new channels to subscribe services to more and more users. Same way, frequency borrowing can be there. Suppose there is congestion over here, we can borrow it from here. We can borrow from the adjacent channel. Same way, cell splitting. Cell splitting is basically the way this is being projected over here. The way how cell can be splitted. This is basically how we can small splitting of the cells can be there, so that more and more subscriber can be subscribed the services. Cell sectoring is being employed when at a particular focused location more and more subscribers are there. Say for example, there is focused subscribers over here, here or here. We can have the sectoring of 120, which is being mentioned over here. If we talk about the omnidirectional, this is basically omnidirectional. Omni. If omnidirectional is there, we use this one. If again there are different sectors in a, you can say angle of 60-60, we can have different sectors being inculcated in a form of as projected in this particular diagram. Microcell and macrocell are again also an you can say way by which we can increase the capacity. We can further just check it out from a very well written book by William Starling, wherein it has been projected. I have given the reference also. It has been projected that cell radius in macro it is 1 to 20 kilometer. In micro it can be 0.1 to 1 kilometer. If we talk about the transmission power, it is 1 to 10 watt and 0.1 to 1 watt. Maximum bit rate is 0.3 megabits per second and 1 megabit per second. Thank you very much for watching this reference. There are certain references which are being projected over here.